Look up at the night sky tonight. You will see the moon hanging there, glowing softly, lighting up the darkness. It has been doing this for 4.5 billion years, every night without fail. Now imagine if it suddenly disappeared. No moonlight, no tides, no romantic evenings under a full moon. Sounds terrifying, right? But here is the strange part. Two planets in our own solar system have been living this exact reality since the day they were born. Mercury and Venus have never had a moon. Not one, not ever. In a solar system where Jupiter has 95 moons, Saturn has 146, and even tiny Mars managed to grab 2, these two planets have absolutely nothing orbiting them. Zero. And the reason behind this is one of the strangest and most heartbreaking stories in all of planetary science. Welcome to Deep Fact, where we uncover the science that nobody tells you about. Before we understand why Mercury and Venus have no moons, we first need to understand how moons are born in the first place. Because moons do not just appear out of nowhere. They have origin stories, just like planets do. And science tells us there are exactly 3 ways a planet can get a moon. The first way is capture. A planet can use its gravity to grab a passing asteroid or space rock and trap it in orbit. This is how Mars got its 2 tiny moons, Phobos and Deimos. They are not round and beautiful like our moon. They're small, irregular, potato-shaped rocks that Mars captured from the nearby asteroid belt millions of years ago. The second way is coformation. When a planet is forming from the swirling disk of gas and dust around a young star, some of that material can clump together nearby and form moons at the same time. This is how Jupiter and Saturn got most of their massive moon families. They were born together with their moons from the same cloud of material. The third way is the most violent and dramatic: giant impact. A massive object crashes into a planet with so much force that it blows out enormous amounts of debris into space. That debris collects in orbit and slowly forms a moon. And this is exactly how our Earth got its moon. About 4.5 billion years ago, a Mars-sized protoplanet called Theia slammed into the young Earth at an unimaginable speed. The collision was so powerful that it melted most of Earth's surface and sent trillions of tons of molten rock flying into space. Over time, that debris came together and formed the moon we see tonight. So moons can be captured, co-formed, or born from catastrophic collisions. Every planet had these 3 chances, yet Mercury and Venus ended up with nothing. Why? Let us start with Mercury, the smallest planet in our solar system and the closest one to the Sun. Mercury orbits the Sun at an average distance of just 58 million kilometers. To put that in perspective, Earth is 150 million kilometers from the Sun. Mercury is sitting almost in the Sun's backyard. And this is where the problem begins. In physics, there's a concept called the Hillphere. Every planet has one. Think of it as an invisible bubble around a planet. Inside this bubble, the planet's gravity is strong enough to hold on to a moon. Outside this bubble, the Sun's gravity takes over and pulls everything away. Earth's Hillphere extends about 1.5 million kilometers. That's a huge space where our moon can safely orbit without the Sun stealing it. But Mercury's Hillphere is tiny. Because Mercury is so close to the Sun's gravitational pull dominates almost everything around it. Mercury's gravity simply cannot compete. Any object that might have been captured by Mercury would quickly be yanked away by the Sun's overwhelming pull. It's like trying to hold a piece of paper in a hurricane. You might grab it for a second, but the wind will rip it away immediately. But there's more to the story. Even if somehow a moon formed near Mercury through a giant impact, it would not survive. Computer simulations have shown that any debris launched from Mercury's surface would either fall back onto the planet, crash into the Sun, or be flung out of orbit entirely. The Sun's gravity creates such chaos in Mercury's neighborhood that a stable moon orbit is almost mathematically impossible. Some scientists have even proposed that Mercury itself might have once been a moon. There's a theory that Mercury was originally a moon of Venus that got pulled away by the Sun's gravity and settled into its own orbit. This has not been proven, but it shows just how unstable Mercury's position is. So Mercury never got a moon because its location is simply too dangerous, too close to the Sun, too small a Hillphere, too much gravitational interference. Mercury was never given a fair chance. Now, let us talk about Venus, and this is where the story gets truly fascinating. Because Venus might have actually had a moon once. Venus is the second planet from the Sun, roughly the same size as Earth, with similar mass and gravity. Its Hillphere is much larger than Mercury's. It is far enough from the Sun that gravitational interference is manageable. Venus had every reason to have a moon. It had the size, the gravity, and the location. So what went wrong? To understand this, you need to know something very strange about Venus. It spins backwards. Every planet in our solar system rotates counterclockwise when viewed from above the North Pole. Every planet except Venus. Venus rotates clockwise. Scientists call this retrograde rotation. And Venus does not just spin backwards, it spins incredibly slowly. One full rotation on Venus takes 243 Earth days. That is longer than its own year. A day on Venus is longer than a year on Venus. Think about that for a moment. Why does this matter for moons? Because of something called tidal forces. You see, when a moon orbits a planet, the gravitational interaction between them creates tidal forces. These forces can either push a moon further away from the planet or pull it closer, depending on how the planet rotates. On Earth, our moon is actually moving away from us by about 3.8 centimeters every year. This happens because Earth rotates faster than the moon orbits, so the tidal bulge on Earth pulls the moon slightly forward, giving it energy and pushing it outward. But on Venus, the situation would be completely opposite. Because Venus rotates so slowly and in the wrong direction, tidal forces would not push a moon away, they would drag it inward. Slowly, relentlessly, the moon would spiral closer and closer to Venus over millions of years. Eventually, it would cross a critical boundary called the Roche limit. The Roche limit is the distance at which a planet's tidal forces become stronger than the gravity holding the moon together. Once a moon crosses this line, the planet's gravity literally tears it apart. The moon shatters into millions of pieces. Some of those pieces crash into the planet. The rest scatter into space. Scientists Alex Alemi and David Stevenson from the California Institute of Technology published a groundbreaking study proposing exactly this scenario. They suggested that Venus was struck by a massive object early in its history, just like Earth was struck by Theia. This impact created a moon around Venus, but because of Venus's slow backward rotation, tidal forces pulled the moon inward instead of pushing it outward. Over hundreds of millions of years, that moon spiraled into Venus and was destroyed. But the story does not end there. Alemi and Stevenson proposed that Venus might have been hit a second time by another large object. This second impact could have been what reversed Venus's rotation in the first place. And any moon created by the second impact would have suffered the same fate, being dragged inward by tidal forces and eventually destroyed. Venus did not just lose one moon, it may have lost two. Venus had moons, and it killed them. This makes Venus perhaps the most tragic planet in our solar system. It had what Earth has, and it lost everything. Now here's the part that should make you pause and think. Earth almost suffered the same fate. If our planet rotated just a little differently, if the Theia impact had happened at a slightly different angle, if our rotation was slower or reversed, our moon could have been dragged inward and destroyed too. Without the moon, Earth would be a completely different world. The moon stabilizes Earth's axial tilt, keeping our seasons predictable. Without it, Earth's axis would wobble chaotically, causing extreme climate swings that could make complex life impossible. The moon's gravity drives our ocean tides, which played a crucial role in the evolution of life, helping early organisms transition from sea to land. Without tides, life on Earth might never have left the ocean. The moon also slows Earth's rotation. Billions of years ago, an Earth day was only 6 hours long. The moon's tidal forces gradually slowed our planet down to the 24-hour day we have now. Without this slowing, winds on Earth could be so extreme that the surface would be uninhabitable. We owe our existence to a cosmic accident that happened 4.5 billion years ago, and we owe it to the fact that our moon spiraled outward instead of inward. Venus was not so lucky. So, the next time you look up at the moon, remember this. That glowing circle in the sky is not just a pretty light. It is the reason you exist. It is the reason Earth has stable seasons, gentle tides, and 24-hour days. Mercury never had the chance to hold a moon. Venus had a moon and lost it. Earth got one and, against all odds, kept it. 3 planets, 3 completely different destinies, all decided by gravity, rotation, and location. In the grand story of our solar system, the moon is not just Earth's companion, it is Earth's protector, and that is a fact worth knowing. This is Deep Fact, and we'll see you in the next one.